Good morning, good afternoon, and good evening, everyone, depending upon where you have joined from. And welcome to another webinar from Data Platform Geeks. Today's session is on indexing in Azure Data Warehouse, and our speaker is Mukund Bhashkar from Microsoft. My name is Satya Ramesh, and I will be the host for your next 1 hour. And Aarti Nambiar is helping me with moderation. So before we move forward, a couple of slides about who we are and what we do. We work for eDominer Systems, under which we have a couple of brands. SQLMaestros, under which we do a lot of advanced trainings on SQL Server, Microsoft Data Platform, and artificial intelligence related technologies, which are called as master classes. And we also have a couple of self-paced learning solutions called Learning Kits and Hands-on Labs. And we are coming up with video courses on SQL Server Performance Tuning and T-SQL querying and programming. We also have a famous SQL Server health check that is all about SQLMaestros. Peopleware India, which is our corporate training unit, and we also have a ERP product called Expand SM ERP. Our today's concentration is on Data Platform Geeks and SQL Server Geeks communities, which were founded by Amit Bansal in the year 2010, under which we do a lot of free in-person events and webinars every month. And once in a year, we do a summit called Data Platform Summit. It is a picture from recently concluded Data Platform Summit 2019, which happened in the month of August in Bangalore, India, wherein more than 1,000 people from 300 plus companies traveled down from 16 different countries to participate in this summit for 3 days. In this regular summit, there are more than 100 plus sessions delivered by 50 plus speakers who are again traveled down from 20 different countries. So if you have to do anything with data analytics, artificial intelligence related technologies, this summit is a must attend for you. If you wish to learn more about Data Platform Summit, you can visit www.dps10.com, or else you can simply drop an email to contact@dps10.com. Here is a picture of DPG team and eDominer team on the stage of Data Platform Summit 2019. And here is the DPG core team: Amit Bansal, who is founder and president, and Manohar Punna, who is vice president. And you can see other regional mentors from various cities in India and abroad. Here are the eDominer teams which are helping us to organize these events. And special thanks to Microsoft for helping us in our community efforts. You're a member of Data Platform Geeks. Remain as a member. You'll get access to free videos, labs, magazines, and other resources as well. And whitelist Data Platform Geeks domain and add events at dataplatformgeeks.com to your address book so that you won't miss any of our updates. If you're finding our emails in your promotion folder or spam folder, move it to inbox so that you won't miss out on any of our updates. And if you have joined today's webinar using direct joining link from Zoom, please go ahead and register for Data Platform Geeks. So you will be able to get opens up this call for speakers and regional mentors. You can find all the details under dataplatformgeeks.com. So beyond this webinar, if you still have questions, you can join our social groups, Facebook, LinkedIn, and Telegram. We do prefer Telegram over WhatsApp because of privacy reasons, and Telegram has a desktop app which will sync with mobile seamlessly. So that's why we do prefer Telegram, and we have a group there. And we do record all our webinars, and all our webinars will be available at youtube.com/SQL Server Geeks. And in our free time, we do record free videos on SQL Server Performance Tuning, T-SQL querying and programming. We do upload them under SQLMaestros YouTube channel. And again, here is the direct joining link to join Data Platform Geeks Telegram channel. So without any further delay, I'll hand it over to Mukund. Mukund, over to you.
Thank you, Satya. Hello, everyone. I'm Mukund from Microsoft, and I have been working as an Azure Data Warehouse engineer in Microsoft from last 2 years. I'm here to organize a discussion on indexing in Data Warehouse. So let me just share my screen. I hope the screen is visible to everyone. I'll take 10 more seconds.
Yes,
we can some more time for others. Okay, so it sounds really great. Thank you, Satya. My last webinar with Data Platform Geeks was on Azure Data Warehouse, the basics of Azure Data Warehouse. So I'm not sure how many of you would have attended that. So now coming in the continuation, so this is a very basic need for any database or data warehouse where we need to specify the indexing. Okay, so indexing, it's a very vital part of any database or a warehouse, even if it's a Microsoft or if it's a IBM or any sort of maybe Amazon. So everywhere there should be a smart indexing technique, right? So today I'll be sharing some of the details about how the indexing works in Azure Data Warehouse. What are the kind of you can say default indexing? Okay, so there are various types of indexing we all know, but what indexing type actually the data warehouse deals with and how efficiently it deals with, because it has to go through massive data, and the queries have to go through massive records, like billions of records, because maybe in OLTP, the number of transactions, the number of rows, or the number of operations, okay, so it may not pass through the billions of rows, it may pass through some number of millions kind of thing. But if it comes to data warehouse, it's a millions or billions or trillions of rows, and we talk about petabytes when we come into data warehouse. So how the select operation or any such query, any such complex stored procedure, when they get inside the data warehouse, okay, so how do they proceed further, and what is the best technique that can be achieved, to get the fastest response from a specific query. So let me go to my the initial slide. So this is the indexing in ADW. So in short, we call Azure Data Warehouse as ADW. So I'll be taking ADW as a reference. At first, then types of indexing in ADW. So what are CCIs? So not sure how many of you would be knowing the CCI, that is Clustered Column Store Index. So in short, we call as CCIs. Nevertheless, we'll go through the non-indexing thing, that is heap. So we call as non-indexing in data warehouse, and the non-clustered column store index as well. So we'll see like if at all this non-clustered column store index exists in data warehouse or not. And later I'll take a few snippets to show you the demo. So let's proceed with the first topic. So you can see here, there are two icons, that is clustered index and clustered index. Both look to be same, but the kind of the pictures that depict it's kind of a different one. So it shows something called binary when we talk about a B tree, and it's something called, it talks about something like columnar structures. Okay, so why is it like the clustered index and the clustered index here? Both are the clustered index. What is the difference? Like if it's a normal clustered index or if it's a clustered column store index. So we'll see all these details in the upcoming slides. Okay, so now when we talk about data warehouse, so it will have some primary data stores and secondary data stores. So the primary data stores, that is we store the data primarily into the distributions in the data warehouse, and the secondary data stores, like maybe we talk about some staging tables, or the tables that load the data into the staging tables that may be outside of the data warehouse as well. Okay, so in the primary data stores, that is inside that Azure data warehouse. Okay, so we have these three kind of indexes. So the first one is heap, that is base row store. So I'll talk about heap later. Clustered index. So it's normal a base row store kind of index. So clustered index we know in database. Okay, so it's a normal clustered index, and we do not name it specifically like clustered row store or clustered column store. But when we come to data warehouse, then we call it as clustered row store index. So it's the same that is in the database, that is clustered index. So we call it as a clustered row store, and there is another index, that is clustered column store index. So what is the difference? I will also cover that in the next slide. And the secondary data stores, like when we talk about some non-clustered indexes as well, for the staging tables or some of the dimension tables as well, like secondary B-tree index as well as non-clustered index that can be on heap, and non-clustered column store index. So actually, is it really a term in data warehouse or not? So we will see that as well. So if I'm going faster, please raise your hand. I'm so sorry. Thank you. Okay, so now here we come through the two topics, that is Rowstore and Columnstore. So the Columnstore, it's very widely known now just because of its the kind of speed that it provides when we select some of the records, not some of the records, basically when we try to select some of the records out of millions or billions of row groups. Okay. Now, at first, we'll talk about Rowstore index. What is a Rowstore index? So if we talk about the Rowstore index, like it's a normal clustered index where the data will be stored in a row format. So basically, it's the same table that we had been seeing from our, you can say, engineering kind of thing. When we started our engineering, when we started our RDBMS concepts, then we used to see, okay, it's a table and the data is being it's being stored in the table in a row format. Like there will be certain columns A, B, C, D, and there will be a number of rows. So that's a row store. And when we talk about indexing on the row store, then we talk about clustered index in a row store. So clustered row store index. And when we create a clustered row store index, then we need to provide a key, that is index key. So that the index key, when we create a clustered index and we provide a index key, then it will sort the data accordingly. So it will sort the data from the top to bottom, and that is the actual work of indexing, right? So to sort the data that is inside the table, so that whenever a query gets fired, gets executed in the database, okay, or in the data warehouse, so that should provide us the result very quickly and in a very efficient way, so that the query doesn't have to look for more number of records. So suppose if I have a query that should provide us the result of top 50 customer names, which starts with XYZ and whose salary is this much. So if we have a proper indexing, then it may scan through some, you can say, out of 1,000 records, it will scan only 60 to 70 records, and it will give us the 50 records what is required. But if we have some non-clustered index, or we don't have an index actually, then it may go through all the 1,000 records and it will give us the result of the last 50 records, top 50 records. So it's more time consuming when we don't use the index. But if we use the index, that is clustered index, then it's less time consuming. So that is how Rowstore index is it means in data warehouse. So in a database, we need to provide the index key, that is the column key on which the index, we have to create the clustered index. Now when we come to column store index, so it's a clustered column store index. Whenever we talk about column store, so it's a clustered column store index. So why the name is column store? So I'll tell you. So suppose you take a normal row. I will show you with an example. So suppose if you So now let's come here directly. Suppose we have these many rows, these many columns, okay, out of which there will be some n number of rows. Okay. Now suppose if we want to check something from that the whole row, or out of that whole table, basically. So there will be, suppose the store key. If you talk about the store key, okay, so store key will be a primary key, but when we talk about the stored name may be duplicate, right? So suppose for 1,000 store keys, the stored name is the same. So in a row store format, we will have all the 1,000 entries, because the stored key is it's a primary key and it is a unique key, right? So for all the store key, there will be the single store name, because it's the same store name, right? But when we talk about column store, okay, then what will happen? At first, the data will be stored in the data warehouse in a columnar way, so that the store key, suppose if we talk about the store key, okay, there will be 1,000 store key entries for the store key. But when we talk about store name, there will be only one entry of the store name value, because it's the columnar in a columnar way. I will go back to the slides. Yes. So suppose this is the format. You see that it's a row format. So suppose there is a table name XYZ in which there are two columns like employee ID and employee name. Okay. So there may be a case that the employee ID will be different, obviously, but the employee name may be same for suppose 10 employees. Out of 1,000 employees, the 10 employees have the same name, but the employee ID is different. Now what will happen? So when we store the data into data warehouse, okay, then this this column, it will have only the employee ID. Okay, this is the first column. It will have only employee ID, and the data will be stored in the data warehouse. So there, if there are in the row store, there are suppose 1,000 employee IDs. Okay, so in the columnar format also there will be 1,000 employee IDs entries. So that is well defined and that is well understood. Now when we come to the employee name, okay, so suppose 1,000 names are same. I'm just taking an example, like out of 10,000 employees, suppose 50, I'll take a 50. So 50 employee names are the same. Okay, so when we talk about 50 employee names are the same, then we'll have 50 different entries in these rows. But when we talk about Columnstore, then we'll have only one entry for all these 50 employee names, because all the 50 employee names are the same, right? So there is no any, it doesn't matter whether we write 10 employee names in the same column or one employee name in the same column. So the column store logic, it says that there will be single employee name a for a for this employee. Okay, so suppose it means that we will be taking a unique value. Okay, so there are 50 different entries for the same value. So there's the employee name, but here there will be unique employee name. Okay, there will be only one entry of the employee name. So this is the employee name, suppose X. Okay, now there are suppose 10 more employee names which are same named Y. Okay, so we'll have single entry here Y. Okay, next entry Z. So all the names here will be unique and different. So you can understand that at first the number of entries that were there in the row format, that has reduced drastically when it came to column store, because we do not allow the duplicate values to be inside our columns when we use the column store index. But when we talk about row store, that was our basic RDMS that we have studied already. In that, we'll have all the 50 entries that will be duplicate entries for the same name, or maybe the kind of the company, maybe the company that they're working for, or maybe maybe the area in which they are located. Okay, so the area may be also same. So there will be only one entry for each specific area in this column. So suppose this is the area column. Okay, so there will be only one entry for, suppose if you're staying in Bangalore, then suppose you're staying in Marthahalli, then there will be only single entry for Marthahalli. If you are situated in Pune, then there will be only one entry for, suppose you say Pune. Okay, so in Pune, I'm residing at Hinjewadi, so there will be single entry for Hinjewadi. But what will happen? This column, okay, each entry will have an address of all the primary keys that are there in the previous column. So suppose my name is X, okay, another employee name is Y, another employee name is Z. So suppose the X employee, it is staying in Hinjewadi, then X employee details will be already updated here, that okay, when I'll look for an X employee, then I will directly come here. But if we see in the row store, okay, then suppose if I check the X employee, where is it residing, then I have to go through all these rows where that employee sits, and then I have to again go to the another column, and again I have to traverse through all these rows that where actually the employee is residing. But we talk about column store, there will be employee name here in this column, there will be employee place where they are residing in this column, that will be unique. So I'll have the query, select the employee name where they reside at, suppose X location. So the query will come here, it will directly look when the employee name is it is found here, back to the place where that is residing, because this column has an address of the next column that where actually the employee is residing. So this is a very basic example of column store. Let me know if you have any queries. Maybe you can just put out your mic, not an issue. Okay, I don't see any question till now. So I hope the basic concept of the column store should be clear. Um, I'm sorry that I could not have the exact example right now. I just tried to explain it over the figure, that is Rowstore and Columnstore. Now I'll take some basic example of some basics of the CCIs. What is a clustered column store index? So clustered column store index. Whenever we talk about Azure Data Warehouse, then and when we create an index, then by default a cluster column store index is created, so that the data will be stored in the data warehouse in a columnar format. Okay. Now column store index, it is always stored in a columnar format, and data is compressed as repeating rows are omitted and not included for each entry. That's what we saw there, right? With an example of the employee which is situated or residing at some X place. Okay. So the number of places that are there in the row format, okay, they are repeating because for each employee it is repeating, right? But now what we say, can we create non-clustered index along with column store index to increase the performance? Yes, we can create non-clustered index as well, but not non-clustered column store index. So it will not have a column store index. It will not have a non-clustered column store index. It should be only non-clustered index. So we need to have in our mind that we can have more number of non-clustered indexes, but there will be only one clustered column store index or clustered index. That is by design. Now, data compressed as, just a second. The data is compressed, that we came to know, and always what the clustered column store index, the clustered index, it always does a scan. So basically, when we talk about scan, so it looks for it makes a overview of the data. So suppose you have millions of records, then it scans the record rather than the seek, because there is a difference. So seek will help if we have very less number of records. Then we can directly point to the place that, okay, my answer is residing at that place. So that is the actual seek. But a scan, it goes through all. When we try to take the data from out of millions of records, then it's actually too much faster. Now it's perfect for larger fact tables. Yeah. So basically, when we talk about clustered column store indexes, then we design clustered column store indexes for only larger fact tables where the row groups size will be at least 1 million. So when we have millions of records, when we have the partitions also. So the partition concept I'll not be covering here, but I'll just let you know that we will be having the partitions, we'll be having the row groups at the backend. So for every partition, suppose one partition has 4 row groups, and out of those 4, every row group has some 10 millions of records. Then the cluster column store index, it fits really fine for the search, from the search perspective when we fire a query. So suppose it can be a select query, it can be any kind of operation like on operation, or yeah. Best for analytic queries that need large set of data to be pulled and put back to the destination. So of course, it is the data warehouse. When we talk about data warehouse, it's an analytic system, analytics platform. It's not a transactional platform. It's not an OLTP. So when we talk about analysis, we talk about bunch of data, a lot of amount of data, and when we try to search, very few results out of that numerous amount of data, then we should have a very smart technique that we can achieve the goal in a very small time frame. And that is where clustered column store index, it really helps us. Now, CCI is continued. So no index key specified as the data is in columnar format. Okay, so since the data is every column, in the clustered column store index, this is the beauty of the clustered column store index, that you can have the every column, it's a key itself. There is no any need of specifying the index key. What we actually do when we create a clustered index in the database, or maybe in the data warehouse also, we create clustered indexes for maybe kind of small tables, like some of the tables that actually load the data into the staging table, or in the dimension table. Okay, so just for loading, okay, maybe we can have the clustered index. But when we talk about search out of the bigger dimension tables or fact tables, then always we need to have the CCI, so that the data will be in a compressed format, it will be in a columnar format, and when we search the data, it gives the result very fastly. The row groups are divided into segments. So now, what actually helps the column store index to search the data so fastly? Actually, so we knew the concept that, okay, at the backend it happens like this, but which term actually it helps the column store indexes to search the data fastly, and that is the segment. So basically, when we create a column store index, okay, then the segments are defined at the backend. And those segments, basically, they have the range. Okay, they have the range that this is the minimum value of the data that is inside this column, and this is the maximum value of the data that is inside this column. Okay, so when the search control goes to that specific column, it will directly match the values, and it will get the values very efficiently. So we'll talk about the segments later, and in maybe in another session, maybe I can talk about the row groups or something. But as of now, I'm skipping it because it's we are trying to cover CCI mostly. So CCI uses segments to traverse through the data to find the exact data. So as of now, you can just think of that. It's the segment that is the that has the range value, and it is basically responsible. When we load more volume of records, we have to, yes, you have got the point, Satsivam. We'll move to the next slide. Clustered row store index. Okay, so data is present in a row format that we saw in the very starting slide, and all columns are included in each row. That is just the RDBMS thing that we have already studied, and that we have been studying from last 5 to 7 or 10 years. Now, may outperform CCI with small range data to fetch the value. So basically, what my second point tells that when we talk about smaller tables, like suppose they have 1,000 records, they have maybe 500,000 records, maybe 1 lakh records, or 5 lakhs of records. Okay, and at that point, when we try to search the data, then we can use clustered index, and that's fine because the data volume is less, and it will do the seek. It will directly do the seek. It will look for the exact data. Okay, it will not scan, it will not search through the data, it will directly look for the data, because the data size is, the table size is very small, the number of rows are very small, and in many ways it will become top on the clustered column store index. It can work much better compared to clustered column store indexes. So that is why I have been repeating that for smaller tables, always use clustered indexes, clustered row store indexes, basically just to differentiate in data warehouse. And for the larger tables, larger fact tables, larger dimension tables also, when you are trying to search out of millions of records, more than millions of records in a row group, then try to use column store indexes. And it is actually recommended in the Microsoft documents. Now, performs seek, of course, and best for smaller dimension tables, have to specify column names to test data that is physically ordered. Okay, so basically you have to specify the name. okay, in the column name, in the clustered row store indexes, and how that is on that specific column. Based on that specific column, the data will be ordered physically, and that is how the clustered row store index works. So this is where we see the difference. So here it's a clustered row store index, and here it is something called clustered column store index. So if any of you have the concept of basic concept of Azure data warehouse, then I will, okay, that is a Q&A. Let me check. Can we create column store indexes online? Yes, you can. Yes, you can, but recommended not to. I will tell you why it is not recommended. All the answers that I'm giving with perspective of Azure data warehouse. Thank you. Okay, so I'll cover that point. Why should we not do that online, and why should we do that offline when there is no any business data and there is nothing going on? So I will come to that point as well. If we do incremental daily load, which one is best? Incremental daily load, CCI or CI? For smaller tables, I will always prefer CI. Can we access the other columns data when index creation is going on? You can, not advisable. I will come to the point why when something is going on like index rebuild or something, then why should not we basically entertain the data warehouse with queries? I'll come to that because it actually reduces the performance like anything when there is an index rebuild or index creation is going on. Okay, so we'll come back here. It's a basic Azure data warehouse create table statement here. Create table. These are the columns. Okay, and with clustered index. So it's a clustered row store index store key. So we have created the clustered index on the column that is store key. Now distribution is the it's we define the data in the data warehouse based on the distributions. So in Azure data warehouse, every data warehouse has 60 distributions, and the data is stored in a fashion like round robin or hash or replicated. So these are the three fashions in which the data is stored in data warehouse. So what is that? Basically, I think you need to explore. Create table. Again here, this is the column store. So create table. In this, we are creating a table and as well as with a clustered column store index. So basically, when we talk about clustered column store index, if we don't specify this name as well, clustered column store index, we omit it. We don't specify this name also, omit it. Just write distribution equals to maybe round robin, or if you're creating a hash distribution, give the hash key and create it, and you will see something that you have got a clustered column store index that is created, and that is created by default. And by default, it creates mostly on the date column, and that is actually not visible to you. So if you explicitly want to create a clustered column store index on a specific table, you can do that. And mostly, it is advisable to create a column store index on a date column. Exclusive lock. So it depends. Rajshekhar, it depends upon the kind of transaction that is going on. But if you are creating, if you are rebuilding index, there should not be any specific lock. Yes, it can be an exclusive lock, but I have seen that I can access the data, but the performance is very degraded. It's very much degraded. Which one is give better performance? Okay, sorry. In terms of load time. Load time, I mean, if you are doing a normal insert, then it's fine. Like CCI or CI, it's a kind of mixed scenario because you're not searching anything. You're just directly putting the data into the data warehouse. So that's fine if you're using CI or CCI. So I think I'm clear here with the name clustered column store index and clustered index. I'll give a very brief demo also for that. Okay. So here, this is the snapshot that I have captured. It will look like this: the clustered column store index. Okay, so when we create a normal table in a data warehouse, okay, so you can see it's a data warehouse basically. We have not created normal table without any kind of distribution type defined, but so it directly creates a clustered index at the backend, clustered column store index basically. Now we'll talk about heap. And this is not basically, when we talk about heap, we don't talk about indexing at all. Okay, and a heap, it's a collection of unordered data. The data will not be ordered. We will not create any clustered index on the table. It's only for smaller tables, which tables are used to load the data into the staging table. So basically, then you can directly, because while inserting the data on the tables, you require very less amount of, you don't actually need too much of index activity. But yes, when the data is entering into the data warehouse or maybe staging table on the destination, then you should have that that kind of indexing technique, that maybe what kind of indexing it is going to create. But at the source end, when you have a source data that is in the heap, then indexing might not be required for smaller tables. And it is best to load the data into staging before transformation, of course. And non-clustered indexes has pointed to the data basically. So non-clustered index, they always point to the data, and the clustered index, it has the data itself at the B tree level. And only one clustered index can be created on the table. I think we are clear about this. Cluster Rowstore indexes, they sort the data physically based on the column. That's also true. And individual disk space required. Yes. So this is the point that I'll be coming on, and it will answer many of the people that are sitting there. Okay. So whenever index creation or rebuild, okay, so whenever it goes on, then then the data warehouse, it actually utilizes hell amount of memory at the backend. So if you would have heard about the resource classes in the data warehouse. So suppose you have a small resource class, okay, in the data warehouse, and you are rebuilding the index in a small resource class, then it will, basically the index creation, it will take too much of memory. It will eat up all the queues that are there for a small resource class, and no any other query will execute. Suppose I have a small resource class, and I have the concurrency, that is, I can run parallelly 20 queries in the small resource class. Okay, so I will rebuild index in one resource class. Now what will happen? At first, the rebuild will take 10 days. Trust me, it will take more than 10 days. If we run rebuild index in a small resource class, and we give a very less amount of memory, because small resource class, it will have very less amount of memory. Now if we increase the resource class to large RC, okay, so when we talk about large RC, maybe the concurrency, it will reduce, because we are giving more memory to each resource class. In that, at that moment, indexing may take, you can say, one day, because I'm talking about larger tables. Okay, suppose they have billions of records, so the rebuild of index, it will take a day. Now if we talk about extra large, sorry, at first small resource class, then medium resource class, and then large resource class. So always it is recommended that always rebuild the index in a large resource class, because while rebuilding the index, don't run any query. It is always advisable to run rebuild index when there is no load, because it reduces the performance of data warehouse like anything. So it is always recommended not use any query while running the index rebuild. And that is why it should be something called offline, that it should be created offline. Okay, I have some questions. What will lock will happen, I hope. Yes. Which one is give better performance for daily load? CC. Okay, sorry, I think I'm repeating. will take care of rebuilding indexes, or we no update statistics. It's a different entity in data warehouse, so it will not take care of rebuilding the indexes. Rebuilding the index, it's a very different part. Can we do rebuild index after load completed? Yes. Yes, you can do that. Thank you. Okay. So that's what I was talking about. So always prefer large rows class to rebuild the index because it takes too ample amount of memory. And when you have updated index clustered column store indexes, then you will see a very good performance. And there will be okay. Space also needed while index rebuild. Yes, we need actually to ample amount of space when we rebuild the indexes, and that is where we always recommend that rebuild the indexes when there is no business load. Thank you so much. And now I will be covering the demo part. So in the meantime, if you have any such query, please feel free. Columnstore index will help in OLTP. Columnstore index, it will help in OLTP, but millions of rows, correct. So you should have a minimum of 10 millions of rows, or minimum of 10 lakhs or millions of records at least. But remarkably, prefer maybe 10 millions of records kind of thing, more than 10 millions of records, because we have seen that sometimes it may help and sometimes it may not help, but it depends upon the data. When you as an end user, when you try to compare the clustered index and clustered column store index in a database specifically, then yeah, you should be very much specific about the column that you are also you're trying to use as a columns as a row store index. Okay, because it may happen that if you have chosen date as a row store index, and then it may give you bad performance, the cluster index, and column store index will give you a good performance. So it depends. I mean, it needs to be checked. It depends, totally depends upon the end user kind of type of data, okay, what it has. But ideally speaking, as per the documentation, what we have done our research, so obviously it's a column store indexes, they always work with a large amount of data, which are in millions. Okay, so right now over here, what this is an Azure data warehouse. Okay, so I will show you on the portal as well how it looks like, and why actually I'm going there, why I'm not coming to database. So basically it's just because I'm covering the indexing in data warehouse, right? Oh, so sorry. So this is my data warehouse. It looks like always data warehouse, it is stored on a logical server. So this is my logical server. On this SQL server, that is logical server, I can always create a new database, or I can create a new data warehouse. So I have a database, I have a data warehouse. So now we are coming to data warehouse. So always a data warehouse, it can be paused and resumed. It can be paused anytime, it can be resumed anytime, it can be scaled anytime, and yes, it can be restored using the geo restore that we have. Okay, so this is the basics of the data warehouse. Okay, now I have connected to this data warehouse, and even one more thing that I can tell you, you can use the feature that is query editor, basically. Why it's not showing? Yeah. So you can directly use the instead of SSMS, you can directly use the query editor. It's in preview, so don't raise cases. Thank you so much. Yeah. Okay. Sorry for that. Okay. Now create a schema. So I have created a different schema just for this session. Now I will be creating a normal table. Okay, and this table will have normal sort of you can say the columns, and we'll try to see that which kind of index does it actually create. Okay, so we can see that my table is created, and let me check what kind of index has it created basically. Okay, so this is the table that I have created, and when we go to the indexes part. Okay, awesome. So this is you can see here, I have hovered my mouse here, so you can see that it's a clustered column store index. It's an index at first, and it's a clustered column store index. So this is the index that gets created by default. And yes, if you want to get more details about it, please go through our online documentation. Now, coming back to this is sort of, you can say, explicitly we are creating column store index. Now again, we have not provided on which column we are going to create an index, because here every column, it's a separate entity and they are an index to themselves. Create table, sorry. So we have created another table, and that is test2. And inside the test2, what we see is that in the indexes. So of course, if it's by default that it will create a clustered column store index, and now since in the second case we have specified it to be a clustered column store index, so of course it must be a clustered column store index, and that is the same. So that these two examples I have taken just to show you all that by default also, and even by specifying as well, you can you find you know, it's a clustered column store index. Okay, now coming to the third option, where we create a clustered index. So when we create a clustered index, then we always create it on a specific column, so that the index column, okay, this clustered index, it will sort the data physically, and then it will help the query to achieve the goal, that is the result, in a faster way. Okay. Questions? Can we update command to what is that? Update command to update data on a table with column store index. Why do we need to rebuild? It's an offline operation. Isn't it possible to reorganize? Sorry, Mohit, we always talk about rebuild, because a rebuild, okay, when we talk about rebuilding the indexes, it basically, okay, I'll tell you in a very brief. Suppose you have edited millions of records, okay, you have updated millions of records. Now when you have edited, maybe deleted, or you can say updated, so there will be fragmentation. Okay, so there will be some of the pages that might have less amount of data, and there will be pages that might have more amount of data. Now logically, logically the updation would have deleted the space from the pages, and even logically the delete statement might have deleted the space from the pages, but the physical deletion doesn't happen. And that is where, if you don't have the indexing updated, if you don't have the indexing updated, means if you have not rebuilt the indexes, okay, because in data warehouse we don't reorganize, we always rebuild the indexes, okay. So if you don't have rebuilt the indexes, then the memory that your query you will see is that it will not basically go it will not work in an efficient way, because it will see that the memory is already the memory that was actually deleted, logically deleted, it's not physically deleted, okay. So we will not have that kind of performance what we actually should have without rebuilding the indexes. When we rebuild the indexes, it will physically delete the space, and it will physically sort the data again what we actually need. So the logical deletion and the logical updation doesn't work efficiently. The physical deletion works efficiently, and that is why we need the index rebuild. And we don't talk about reorganize, sorry, in data warehouse, okay. Now create table in the clustered index, okay. So I think we have created test 3, yeah, okay. So we have created the table, and okay, so this is the clustered index, and we see here, right, it's a clustered index and it's not a clustered column store index. So it's a clustered index. Updation and insertion needs a rebuild index. Updation and insertion needs a rebuild index. I did not get your question, Satsivam. No, update command. If you want to update the command, if you want to select something, then you should have the index rebuild. But just for insertion. But yes, what happens that insertion, it's not a simple insert statement what we write in a table, because when we insert into, then we try to select some from a specific tables also at the backend, because the insert statement, it can be inside a stored procedure. When you insert into, okay, then you insert into and then select these details from specific table, and again you make a join on that table, because it's not a single insert. If it's a single insert, you're just putting the data into, just like I told that if you have a table that you want to load from that table to the staging table, so it will be a normal insertion, just the raw data, you are transferring the raw data into the table. Now if you have just the insertion part, then obviously you don't need the indexing. But if you have inside the insertion, you have to select from various tables, then of course it needs that. Okay, sorry, I could not get that SCD. I'm so sorry. Okay, I'll take some questions offline as well. Thank you so much. Okay, so create this is how we are creating the cluster index. Okay, now I'll show you that how do we create a heap, okay, where we actually don't specify, the indexing. And that's your answer, Satsivam. So you may use the heap tables when you don't have any, when you actually do, you just want to get rid of the indexing part. Actually the customers, all many of my customers, they actually want to get rid of this. Always I suggest them, but no, I can tell you that's not the recommended, okay, because you should not I mean it's a one-time job. You will set up some of the jobs to rebuild the indexes, but you can see that every day you will be benefited. But if you just want to get rid of that specific time just to create the jobs, and you'll keep on using the heap tables, then every day you are wasting more time of your you are wasting basically more time of data warehouse, and then you are wasting more money on the data warehouse, because you need to keep the data warehouse online for more number of hours. And that is where I mean maybe sometimes my customers don't understand that. Okay, so I have created a heap table, and for smaller tables it's a boon, it's very good. But for the larger fact tables, please don't use. Can you see indexes? There is no index. because a heap, when we use heap, it means that we're not going to use indexes. So it was a very small demo, and it was a very small session, I hope, because I really enjoyed having this session, and I really enjoyed being with you all. I'm totally overwhelmed with the kind of response that I have got here in the in this session. So thank you so much, Satya, and I'm done with my session. Any one of you have any such query, you can put it over the common page or some kind of Facebook pages. Maybe Satya would give, so that if possible, I can answer on that anytime. Thank you so much.
Yeah, thank you, Mukund. We have already posted a thank you note on LinkedIn. If people want to put up questions there and feedback there, they can use that. The link is available in chat window. So all of you can use that link to post your feedback, comments, and if you still have questions, you can use that link as well. And if you still have questions beyond this webinar, sorry, yeah. So you can use our social channels to join to post your questions. So here is our Facebook group, LinkedIn group, and Telegram channel as well. And as I told you, SQL Maestros is coming up with video courses on SQL Server Performance Tuning and T-SQL querying and programming, which are based out of a master series on masterclass or on our famous master classes as well. And uh, SQL Server Performance Tuning course contains more than 100 hours of content, and there are more than 20 plus advanced level modules which will be constantly updated. And the main advantage of subscribing to video courses is that you can watch anytime, anywhere, and as many times as you can. And if you wish to learn more about upcoming video courses, you can visit SQLMaestros.com, or else you can write to us at contact@SQLMaestros.com. And SQL Maestros also have a self-paced learning solution called Hands-on Labs, wherein you will be provided with a lab document which that contains scripts and supporting explanations, observations, and screenshots. So at the end of the document, you will be able to become expert in that particular topic. So there are already more than 100 plus labs available on SQL Server, Azure, Power BI Analytics, and Cosmos DB, and there are close to 2,000 subscribers already subscribed and practicing and benefiting out of hands-on labs project. If you wish to learn more about hands-on labs, you can visit SQLMaestros.com. There are a couple of free labs are also available. You can download them, practice, and if you wish to subscribe, then you can write to us at contact@SQLMaestros.com. And there are so many upcoming webinars lined up. Next week we have one webinar, and after that we have few webinars in January and February as well. All the webinars you can visit at dataplatformgeeks.com/events, and you can register. And here are the social channels if you wish to follow. And again, I'm repeating, the thank you post has been posted in LinkedIn, and the link is available in chat window. So please provide your feedback, comments, and if you still have questions, you can ask there, and we'll get the questions to Mukund so that he can answer those questions. So thank you all. Thank you for being part of this webinar. And thank you very much, Mukund. You have taken out time from your busy schedule, and you have spent your time with our community so that everyone.
No problem, Satya. Thank you. I'll leave now. Thank you so much. Have a wonderful day. Bye-bye.
Thank you all. Thank you for joining. See you in next webinar.